Okay, let us begin today's session. First, we will see modes of heat transfer. Now, let us say um, there is a block which has to be shifted from point A to point B, and I place people here like this. I place people here. There is a person A, you give the block to this person, he gives to this person, then from here, then from here, then from here, he passes on, and finally the block reaches to the person B. This is one way. Take another situation. This block is there. This block is given to this person. Now he simply walks to location B and he gives it to the person B. Third, the block is given to A and he kind of direct transfers to B. He kind of throws it to B. So these three possibilities are there. In the language of heat transfer, this is called conduction. This is called convection. And this is called radiation. Alright. So here what happens is, in conduction, suppose you take a iron rod. Okay. You heat the rod at one side. What happens is, heat transfers to the other end. So this type of mode is usually seen in solids, in good conductors of heat. Okay. So here basically what happens is, the molecules here are heated up, so their kinetic energy increases. So these are all particles of this solid rod. So they just transfer the kinetic energy to the nearby molecule, and so on and so forth. There is a chain, there is a formation of a chain, and the heat from this end to the another end, it is transferred. Okay. Now convection is seen in fluids, usually liquids or gases. Here, as I've explained to you, the fluid molecules transfer the heat. Okay, they carry the heat with them, and finally it is taken to the other side. Okay, so heat transfer happens in this mode in fluids, liquids or gases. When you heat water in a container, basically that container is a solid. So from the solid to the liquid, the heat is transferred, and from a liquid, inside the liquid, the mode of transfer will be convection. Okay. The third one is radiation. Radiation basically is electromagnetic waves. Electromagnetic waves. The first thing is, they do not need a medium. A medium is not required here. The live example is your sun, and you are standing here. You're getting heat from the sun in the form of radiation. You might have heard this UV radiation and all those things. So this is the form of radiation where there is a direct transfer, where there is no medium is required. Okay, the travel speed will be the speed of light. That is why you see the radiation from the sun reaches to in such a fast way. Okay, these are the basic three modes of heat transfer. So when we talk about conduction, so we denote heat as Q, right? So here the formula is K e to A T hot minus T cold divided by D. So this is the heat transfer transfer per unit time. K is the coefficient of thermal conductivity. Different materials will have different coefficients of thermal conductivity. A is the area of the surface or the barrier. T hot minus T cold is difference in temperature. The heat is transferred from higher object at higher temperature to the lower temperature. D is the thickness of the barrier. Thickness of the barrier. This is the equation you use. Here heat transfer is per unit time. If you multiply with the total time, you get the total heat transfer. Okay. So this is the equation you use for conduction. So similar equation is seen for convection also. Here also Q is equal to, it is Hc into A into Ts minus Tf. Okay. So similar to this is the convection coefficient. It is the convection coefficient. A is the area of the surface and Ts minus Tf means, Ts means temperature of the surface. Let us say you are heating water in a beaker. So what happens is that surface is basically a solid surface, and this Tf is the temperature of the fluid. Okay. So these are the two equations we use. Now let us now move to this concept that whenever you take an object, it is a good conductor of heat. Okay. You give heat to this object. You give heat to the object. Basically what happens is some heat is absorbed by the object, some is reflected by the object, and some part is radiated by the object. These three modes happen actually. You take any object, you take a piece of iron, you give temperature to it. What will happen? The temperature of the iron will increase, and some heat, let us say you have given 100 joules. So let us say, I'm just giving just a random example. 20 joules is used for absorption, 40 joules, let us say, for a reflection, and this is transmission. So 40 joules is for, let us say, radiation purpose. So when you give heat to a good conductor of heat, what happens? It will absorb, and after some time, if you kind of put your hand somewhere very close to it without touching it, see, radiation doesn't need a medium. It doesn't need a contact to contact, molecule to molecule contact is not required. There will be direct, supply of heat. So when this is heated up, this iron piece is heated up, what happens is when you kind of go close to that, you feel some heat. That is basically radiation. Okay. So here we can make a deduction that, let us say, Q is the amount of heat which was supplied. Q is the amount of heat which is supplied. Then, so some part is used for absorption, some part is for reflection, and some part is for radiation purpose. Okay. So divide both sides by Q. We get 1 is equal to QA by Q, QR by Q, and QTR by Q. So all these three are called some coefficients. Okay. This is called coefficient of absorption. Suffix A is indicating that, coefficient of reflection, and coefficient of radiation. So here this is denoted by A, this is by R, and this is by TR. So this is equal to 1 unit. Okay. So if 1 unit of heat is given, Some part is taken for the absorption, some part for reflection, and some part for the radiation purpose. So here this, let us say Tr is a coefficient. If it is not equal to 0, that means some value is there. Such type of materials are called diatherm diathermous type of materials. Diathermous type of materials means what? So definitely some radiation is happening. So these are those type of substances where some radiation is happening actually. There can be a case where Tr, some particular material you have chosen, Tr can be equal to 0. So in that situation what happens? It is A plus R is equal to 1. So here no radiation is there. So it is called, those materials are called opaque to radiation. They are called opaque to radiation or athermous type of substances. Okay. So here A plus R is equal to 1. There can be a situation where you have in the same equation A is equal to 0. Okay. A is equal to 0 and Tr is equal to 0. So it gives rise to R is equal to 1. So what is the meaning of this? So whatever heat you are giving to the substance, entire heat is reflected. Entire heat is reflected by the object. Okay. These are all in a mathematical way we are discussing. So another scenario can be R is equal to 0. If R is equal to 0, then A becomes equal to 1. A becomes equal to 1 means what? Whatever heat you have given is totally absorbed by the object. Whatever heat that is given, 100% heat is absorbed by the object. You know, this is the phenomena that we studied about black body radiation and all those things. Okay, actually 100% absorption, that is called perfect black body. If you find this type of a material, you call it as perfect black body. That means whatever heat has been given to it entirely is being absorbed by the absorbed by the material. So it is an ideal situation. Such type of things is not there. One lamp black is there. It absorbs 97% of the heat. Okay, it is very close to the perfect black body. So these are some points. So here we have seen diathermanous, athermanous type of materials. Here examples can be glass, quartz, hydrogen, oxygen. Okay, and this is water, wood. Okay, iron, copper. Now diathermanous, what happens is this Tr value is not equal to 0. Okay, if Tr value becomes equal to 1, that entire thing it is radiating actually. Okay, so you can say here that they are neither what are the three things? Absorber, reflector and radiator. So diathermanous type of materials are neither good absorbers nor reflectors. Okay, most of the materials what we find are basically opaque to radiation. Okay, so in opaque to radiation you have this equation A plus R is equal to 1. You are saying that Tr is equal to 0. So if A is equal to 1, it is a perfect absorber. If it is R is equal to 1, it is a perfect reflector. Now while we talk about these things, let us talk the case where you have A is equal to 1. What is this? It's a perfect absorber. So a perfect absorber is basically a perfectly black body. Okay, this is an ideal scenario. It is non-existent in nature. It is not possible in nature. First of all, it is non-existent. Ideal person. You find real people in the world. You don't find ideal people in the world. You find real people in the world. Okay, so here A is equal to 1. You are saying that 100% you supplied 100 joules of heat and the body absorbed all the 100 joules. Okay, in real scenario, you get Ferry's black body. You get this type of black body. This is constructed in a laboratory by the scientist called Ferry, and here the absorption percentage is 97%. That means you supplied 100 joules of energy and 97% was absorbed by the body. Remaining 3% you can say it went in reflection. Okay, so the in a way the example is lamp black. The example for this is lamp black, which is used to construct a a setup. The setup is something like this. It is something like this. There is a small gap which is left over here. From here the energy is sent. Which type of energy is sent? Heat energy is sent. Okay, and what they do is they can keep the body like this. Now it is a double walled structure. A double wall. It is quite thick. Okay, this is a double wall construction. The purpose is, see here the entire thing is air, right? What if from air some heat is going inside this setup? Then your whole experiment is disturbed. So this arrangement, it ensures that there is no heat transfer. There is no heat transfer from surroundings. Okay, you're sending heat energy here. Now you're studying a body. Okay, you're studying a material called lamp black, but the condition is that the heat from outside should not disturb your arrangement. So for that purpose they make a thick double walled structure which allows no heat actually from outside to inside or inside to outside. So it is possible because this is a material. So what type of heat transfer is possible here? Conduction is possible. Okay, conduction would be a way in which the heat will be transferred. And if you send this energy straight away like this, imagine this like a mirror, it will again send it back. So in order to avoid that, what they do is they try to put a aperture here. They try to put a aperture here. A conical type of aperture is kept. Okay, and this inner portion is there, no? This inner portion of the first wall. This is my first wall, this is my second wall. The first wall inner surface, they polish it with this substance, lamp black, and they send the heat waves inside this. So what will happen? The heat rays will hit this aperture. So once they hit the aperture, because it is at some kind of curvature. The curvature is something like this, it some heat wave got here and was incident. Let me draw it again. So the setup is like this. This aperture I'm drawing, so it is kept like this. So heat is falling on this, obviously it will reflect. So whatever that fell on this will reflect. Again with this surface, again it will reflect, again it will reflect, again it will reflect, and so on and so forth. This process keeps on going. That means it will go like this. Okay. So basically what is happening, what are these lines? These are all multiple reflections. Till what time it will happen? You went into a street, that street is like this, then it turned, then it turned, then it turned. You kept on turning like this, and finally you are tired. You are tired. Similarly, these heat waves also will be tired, and what will happen? It will be absorbed by this material, which is lamp black. They will be absorbed. Some part is lost in reflection, but the remaining part will be absorbed by the lamp black. And how much percentage? 97% approximately. So this is a real black body which is constructed in a laboratory. So this is the difference between perfectly black body and a Fairy's black body.